So we are still looking at integration techniques. This time around, we are looking at another technique whereby you are given an expression, an integral expression, x squared plus a squared dx, and also x squared plus a squared dx. So how do you evaluate an integral of this expression? I'm going to start with this one. So we are going to formulate an expression that we can use to simply evaluate this integral. So here we are going to use a substitution again, right? So now here we are using the same method that we've been using. We are going to use an x substitution in terms of x is equals to a sine x is equals to a sine theta. So this is the substitution that we're using when it's x plus a squared. But remember, when it was x squared minus a squared, we used x is equals to a cos theta. So don't mix that up. Be careful when you're evaluating, when you're deriving the expressions. So now where there is x, we're going to substitute this expression. So 1 over root a squared sine 2 theta plus a squared, and then what is dx? So dx is going to be dx d theta is equals to a cos theta, right? Therefore dx is equals to a cos theta d theta. So here, instead of dx, we're going to have a cos theta d theta. So we factor out a squared. We're going to have sine squared theta plus 1 a cos theta d theta, right? And then here we're going to use the identity cos squared theta minus sine squared theta is equivalent to 1, which means cos squared theta is equals to 1 plus sine squared theta, right? So here we are going to substitute cos squared theta. So the integral of 1 over root a squared cos squared theta a cos theta d theta. So if you evaluate the roots, we are going to have a cos theta times a cos theta d theta. So this will divide, and then we are left with the integral of d theta, and the integral of d theta is what is theta plus c. And then obviously we need to find what is theta in terms of x and a, because those are the initial variables that we're given. So we come back to the same expression here, whereby we said x is a sine theta. So we make theta the subject to the formula, which is going to be x over a, right? Sine theta is equals to x over a, and then theta is equals to the inverse of x over a, right? So now you know that if you're evaluating 1 over root x squared a squared dx, you should get x over a plus c. So this is another important integration techniques that is very useful when you're trying to simplify complex integrals. So we are going to look at another one where we are looking at the integral we are looking at the integral of x squared plus a squared dx. So here we are still using the x is equals to a sine theta, right? So again, if we continue with this one, we will see that the integral where there's x, we substitute a sine theta squared plus a squared dx, and then of course we need to evaluate dx, right? So how do you evaluate dx? So dx here is a cos theta d theta, and then from here we are going to factor out a squared, because this is going to be a squared sine squared theta plus 1, right? And then for dx, we have, for dx, instead of dx here, we are going to substitute this, so it's a cos theta d theta. The reason why we are substituting theta is to simplify the expression so that we can work it out using the integration techniques that we already know. So this one, if you evaluate, I can use the identity here. So if you use the identity, you're going to have a squared cos squared theta, and then you have a cos theta d theta. So if you evaluate the root is going to be a cos theta, also the side a cos theta d theta, right? So a is a squared, which is a constant, cos squared theta d theta, and then again trigonometric function raised to the power 2, so we use the double angle integrals. So we know that cos 2 theta is equals to 2 cos squared theta minus 1, right? So if we make this substitute the formula, then we substitute here, we are going to have cos squared theta is equals to cos 2 theta plus 1 over 2, right? So we come back and substitute here. So a squared, the integral of cos 2 theta plus 1 over 2 d theta, right? Factor out 2, so we have a squared, the integral of cos 2 theta plus 1 d theta, right? So now a squared over 2, we can evaluate this integral, which is going to be sine 2 theta over 2 plus theta plus c. Again, we are looking at sine, so sine 2 theta is equals to, if you're using the double angle integrals again, it's going to be 2 sine, it's going to be 2 sine theta cos theta, right? So again, we come back to the first expression that we stated here, that we substituted with. We know that sine theta is equals to x over a, right? So here we are going to substitute that. So this is equals to 2 x over a, and then what about cos theta? We're going to use the same identity here, this one, right, to make cos the substitute of the formula. So if you make cos the substitute of the formula, so cos theta is going to be root 1 plus sine squared theta, right? But we know that sine is what? It's x over a, so this is the same thing as 1 plus x over a squared. So we are going to substitute, instead of cos, we are going to substitute this expression. So this is root 1 plus x over a squared. So we come we can simplify this to be 2x over a. This is root a squared plus x squared, right, over a. This is equals to 2x over a squared root a squared plus x squared. And then now here we are going to substitute this expression. So if we continue with this integral, we are going to have a squared over 2, so 1 over 2, right? This is the 1 over 2, and then we substitute this. Sine 2 theta is equivalent to 2x over a squared plus x squared, right? And then plus theta. What is theta? We know that theta, using this, we can make theta the substitute formula here. So theta is equals to sine inverse of x over a. So we come and substitute theta here. Which is plus sine inverse of x over a plus c. So now if we simplify this, we are going to have, obviously, 2 is going to divide, right? And also this is a squared. This is a squared, because yes, a squared, yes. This is a squared, so this is going to be a squared. So this is going to be x over 2 root a squared plus x squared plus sine inverse of x over a plus c, because a squared is going to divide, and you're going to be left with x and 2. So now we know if we find the integral of x squared plus a squared dx is the same as x over 2 root a squared plus x squared plus sine x over a plus c. And integration techniques are very important, especially when you're looking at centroid and statics. You apply these types of integrations. So this is another form of integration techniques that we have looked at. So in the next video, I'm going to touch on other integration techniques, and we are going to look at the reduction formula and continue from there.